Research I do is in the field of planetary science and has two components that are relevant for studies in microgravity research. One is the early stages of the formation of the planets. The very beginning of the solar system, you had dust and gas, and those dust particles stick together and gradually grow larger and larger objects. Once they're very large, the gravity between those objects helps them stick together. But getting them to that size has proved a theoretical challenge. In order to study those collisions between small particles to see under what conditions they stick to each other and when they break apart, to do that experimentally, we need the long duration microgravity environment provided by the International Space Station. Those same types of collisions are actually also relevant in Saturn's rings and other planetary ring systems, where the collision velocities are very slow and the particles are very small and have a negligible gravity. So we're also studying the evolution of Saturn's rings experimentally by doing collision experiments in microgravity. Well, our initial experiment is a small experiment that's designed to look at collisions between different kinds of particles at very low speeds to look at how much energy is lost in those collisions. So we're just going to be using a small video camera to track the particles during their collisions and see how fast they're moving after the collisions. We've got a chamber with a number of different sorts of particle samples in it. Once it's in orbit, we'll agitate that chamber to get the particles bumping into each other gently, and then we'll just collect video data and see those collisions gently damp out over time. We're using different sorts of particles with different densities, some of them with powder coatings, to try to understand how those different parameters affect how much energy is dissipated in the collisions.
Is this a unique experiment?
To my knowledge, this particular experiment hasn't been done on space station. Experimental studies like this have been done before. I think we're going to be able to get to a lower collision velocity regime and explore some different kinds of particles than have been explored before. But this is a prototype experiment for us, and we'd like to develop it into a larger experiment where we can do longer studies of bigger particles. This particular experiment is got a ride up to space that's funded by NanoRacks in Space, Florida, but the experiment itself is developed at the Center for Microgravity Research, which is at University of Central Florida, and the experiment was designed and built primarily by undergraduate students at the university, so they work in the lab. They're getting real hands-on experience in building real space hardware, learning how to work through the inevitable problems that you run into in trying to get things to fit in within your mass and power constraints and that sort of thing.
What do we learn from this?
Well, we're learning how do planets form? Where did the Earth come from? How odd is it that we've got a planetary system with planets like we have today? Under what conditions do planets form? How frequently might they be forming around other stars? What are the conditions necessary for that? So it's about the history and the origin of our own solar system and planetary systems around other stars.